So, hey guys, I'm Jaydeep here. Today we'll be talking about one of the most used binomial identity, which we see many times, and it helps in many ways for the optimization and the reduction of a problem into simpler problems, right? So the identity goes like this: 1 into nc1 plus 2 into nc2 plus 3 into nc3 up to n into ncn equals to n into 2 raised to n minus 1. Now, there are multiple mathematical proofs which you can find online, where the simple approach is just take a binomial coefficient and binomial theorem basically, and do the differentiation on both the side while substituting x and y equals to 1, and you will get the answer. But let's talk in terms of intuitions, right? So I personally came across this through intuition rather than maths. So see, let's see how we can see it in terms of intuitions, right? So the right hand side term is n into 2 raised to n minus 1. So what you can think is that the first N stands for choosing the captain of our team, okay, and the rest of 2 raised to n minus 1 is the freedom we give n minus 1 people whether they want to join the team or not to join team, right? So if you see it carefully, what we can feel is that here n it stands for in multiplication giving chance to every player to become a captain, and once the player becomes the captain we are giving him 2 raised to n minus 1 options to form a team, right? Because we are giving every rest of the n minus 1 players choice to join the team or leave the team, right? So there will be the size of the team will always be greater than or equal to 1. Now this is because we are already choosing one of the player as a captain, and captain will always be there in the team. Now we are giving choices to the rest of the n minus 1 player, and it might happen that none of them joins the team. So in that case the size of the team will be 1. So minimum size will be 1. And what will be the maximum size? The maximum size will be our captain is in the team plus the rest of the n minus 1 players also joins, and hence the size of the team maximum will go up to n, right? Now as we saw that the team size varies from 1 to n, we can also write the same thing in different way, right? So what here I am doing is that here I am trying to take all the possible combinations of teams of size 1. Here I am trying to take all the possible countings for the team of size 2, team of size 3, so on and so forth, team of size n. Now, one thing we must realize is that all of these cases are disjoint, and it's very trivial to understand because the team size are in fact different. So how it can be the case that one team occurs in 2 as well as in 3? So that's never gonna happen, right? Now let's look at how to find all the combinations corresponding to each team size. So let's say we are talking about team of size 1. Now if I want to make a team of size 1, how what should I do? I should first choose the one player out of n players, so that will be done by nc1, and out of those one player I need to make one as a captain, so it will be nc1 into 1c1, which is nothing but 1 into nc1, right? Now let's see, if I want to make the team of size 2, what I need to do. In order to make the team of size 2, what I need to do? First of all, I need to choose the 2 players out of n players, and after choosing those 2 players, I need to make captain. So those among those 2 players, I need to select one which will be captain, and it's translated as 2 into nc2. Okay, so this will reduce to 2 basically. I had exchanged the order over here so that it will resemble to the LHS more. Now let's say I want to make the team of size I. Okay, so in order to do that, first I need to select the I players for my team, and after selecting the I players I need to choose one of them as a captain, and that can be done in IC1 ways, right? So it will be I into nci. So I guess you now able to get the intuition behind how the whole things are running. Okay, So I will summarize this by once more explaining you the RHS. See, in the RHS, what we were doing is that n into 2 raised to n minus 1. So what indirectly we were doing is that we were choosing each player as a captain, and there were n players, so that's why the first term is n, and corresponding to each player we were forming all the possible teams of, means all the possible members of the n minus 1 players, right? So each of the player we gave two possibilities: either he will join the team or he won't join the team. So there will be 2 raised to n minus 1 teams possible, right? So this was for the right hand side, and from the right hand side we can easily understood that the team size will be minimum 1 when there is only captain and none of the other player joined, or the team size will be maximum n when all of the players join to the captain, right? Now, in order to solve that, we can break up the problem in terms of size of the teams, and see, on the LHS we had done this exact same thing. Here we were choosing the team of size 1 first through NC1 and made the one of the player as a captain. Here there was only one player, so 1C1 reduced to 1. Here we choose two players to make the captain, and sorry, to make the team, and out of those two we choose one as a captain. For that we had 2C1, and hence it is a 2 because 2C1 reduces to 2. So I guess you now able to feel what's the intuition behind this. So I hope you had enjoyed this. uh, it would be very nice if you subscribe, but please turn off that notification thing so that you won't get distracted. Take care of your time and take care of yourself. May the force be with you guys.